Hello everyone. In today's video, we will learn how to use an ESP32 microcontroller to read data from an encoder and control a stepper motor. Encoders and stepper motors often generate electrical noise. To solve this, I designed an isolated circuit. This circuit protects the ESP32 and ensures clean and stable signals, similar to industrial systems. Now let's look at the required components. You will need an ESP32 WROOM32E module, a 24V to 5V DC to DC converter, an AMS1117 3.3V regulator, 6 AT6N137 optocouplers, 6 AO3400 MOSFETs, SS34FA diodes, resistors such as 1000, 2.2000, 4.7000, 10,000 and 15,000, capacitors like 0.1 microfarad and 470 microfarad, connectors and headers, an encoder with A and B output, and a stepper motor driver such as TB6600 or A4988. Now let's understand how the circuit works. The design has three main sections. First, the power supply section. We input 24V DC. A resettable fuse and a TVS diode protect the circuit from voltage spikes. Then a DC to DC converter steps down the voltage to 5V. After that, the AMS1117 regulator converts it to 3.3V for the ESP32. Capacitors are used to filter and stabilize the power. Second, the ESP32 microcontroller section. The ESP32 runs on 3.3V. Its GPIO pins are used for input and output. TX and RX pins are used for serial communication. The J2 header is used for programming the ESP32 using a USB to serial converter. Third, the isolated input and output section. For the input side, the encoder A and B signals pass through optocouplers. These optocouplers transfer signals using light, not direct electrical connection. This protects the ESP32 from noise and high voltage. Pull-up resistors help keep the signals clean. For the output side, the ESP32 sends signals to MOSFETs. These MOSFETs drive optocouplers, which then send signals to the stepper motor driver. The step and dire pins receive these signals. This side is also isolated, so high voltage does not reach the ESP32. There is also a bonus header called J3. It provides 3.3V, 5V, ground, and I2C signals. This part is not isolated and is used for sensors or displays. Now we will perform the hardware check. As you can see, we have a stepper motor, a stepper driver, and an encoder connected. Now let's run the motor and observe the behavior. If we apply a signal to input 1, the motor will rotate in the forward direction. If we apply a signal to input 2, the motor will rotate in the reverse direction. If we apply a signal to input 3, the motor will run forward for 5 seconds and then reverse for 5 seconds. That's it for today's video. We have successfully tested the hardware and verified the system is working properly. I hope this tutorial helps you understand how to control a stepper motor using an encoder with an isolated ESP32 system. If you found this video helpful, please like, share, and subscribe to the channel.